Come on, give a break.
Oh
Right,
dear.
here we go.
Yeah.
Hello and welcome to another edition of the Kiwi Astronomers. My name is Gareth Davies. I'm here in lockdown Auckland. I'm a keen amateur astronomer, and I have with me again today John Drummond. He is former president of the Royal Astronomical Society of New Zealand, and he runs the Possum Observatory and Gisborne night tours. What is it, John?
Gisborne Astro Tours.
Gisborne Astro Tours.
Yeah,
that's right. That's right. Sorry. And we're here today to talk about the moon. And interestingly enough, a lot of us are not big fans of the moon because it's the biggest polluter in the night sky. And we're always hoping that the moon will disappear, and then we can go out and see all the wonderful things you can see in a dark night sky. But that said, a lot of people love the moon, and in all honesty, when we go out and we do observing with groups of people, it's always the moon they go wow about. So for all of you out there who are observers, John is going to tell you the story of the moon and what's interesting to see and what's worth seeing and how it came to be formed and all of that good stuff. So I'll pass you over to John now to start the talk. John.
Yeah, no, thank you, Gareth. Yeah, so the moon is, well, humans have known about the moon since inception, and we've noticed certain things about the moon, like phases of the moon, how the moon takes 1 month to go around the Earth. But the word month basically comes from the moon, like the word month. I'll see you next month, shortened to month. And the moon takes a month to go around the Earth. The moon is actually orbiting the Earth. It's not orbiting the sun as such, like the Earth is orbiting the sun once per year. The moon is orbiting the Earth once a month, and it goes through 4 main phases. The new moon, when we can't see the moon, because from Earth we're looking at the unlit backside of the moon, the side of the moon facing us. It's not lit up by the sun, and so we can't see it. And then as the moon goes around the Earth, it goes through the phases. So we see the crescent moon coming up to the first quarter moon, also known as half moon. It's called first quarter moon because at that stage the moon has covered a quarter of its orbit around the Earth. And so, yeah, we call it the first quarter moon when we see half the moon lit up. 1 week later, it's the full moon, and the full moon rises when the sun is setting. So it's quite neat if you have low horizons. You see the sun setting in the west, and you'll always see the full moon rising as the sun is setting. 1 week later, actually 8 days later, we have the last quarter moon, and then 7 days after that, we're back to the new moon. So we're at it all together, and it works out that it's about 25 and a half days roughly from new moon to new moon.
It's all a bit confusing, isn't it, the moon, for some people? Certainly was for me, that new moon, there's no moon, and then full moon is only really halfway through rather than at the end. And then the dark side of the moon isn't really dark. So there's a lot of sort of, and then I'm not sure people really understand, how the tides work and all that. There's a lot of confusion about it, but there's nothing more beautiful in the sky, is there? Especially that in the evening when you suddenly see it rising. That is something really special, I always think. And people drive by in their cars or walk by with a dog. I'm always there staring up and thinking, wow.
Yeah. Yeah, that's right. You're right, Gareth. When the moon is, especially the full moon, is rising at sunset, it's quite amazing how when it's rising, it just looks absolutely huge compared to 6 hours later when it's high up in the sky. And astronomers believe that it's basically a psychological effect where we're seeing the moon in comparison to trees and distant houses and things like that. Because our eyes, our brain has something to compare it with, the moon looks much larger down at the horizon than when it's high up in the sky. It's quite interesting. A few years ago, I was driving down one of the roads to the surf in Gisborne here, and there was a cruise ship out in the bay when we had cruise ships before COVID. And the cruise ship was sitting in the background with houses and trees and everything in the foreground, and it looked absolutely massive. And then when I got to the beach and saw the cruise ship sitting on the in the water without the foreground objects, it looked a lot smaller in my brain. So the moon does a similar thing. Well, actually, our brain does a similar thing when it has these foreground comparison objects to compare it to the full moon.
Yes, I understand they did a study in America, and in fact, young kids thought that the moon at the horizon was twice as big as the moon in the sky. Yeah. So, but you can confirm, right? It is an optical illusion.
It's an optical illusion. It's no larger. So in astronomy, well, a full circle is 360 degrees. So if you looked at a star directly over you, for example, and went right around the sky back to that point in this that star in the sky, that's 360 degrees. The moon, it extends or subtends for half a degree on the sky. And doesn't matter if it's at the horizon or high up in the sky, it's still half a degree on the sky.
Wow.
And interestingly, the sun also extends for half a degree on the sky, which is very unique in that when you get the moon covering the sun for a solar eclipse, the two are perfectly aligned and line up perfectly over each other. Basically, the moon is 400 times smaller than the sun in diameter, and the sun is 400 times further away than the moon. So it gives a 1-to-1 ratio. And when you have the moon sitting over the sun, it's just perfectly eclipsed for a solar eclipse.
Have you been to a solar eclipse, John?
Yes, I have 2 of them in China, one in China and one on a cruise ship, actually, in 2000 and, when was that? 2007-ish, around about then. And both were amazing. It's really neat to see the sun slowly being eaten up, so to speak, by the moon as the moon slowly moves across the sun. And then at totality, it's really dark. It's like nighttime, and you can take your filters off your eyes and everything and look at the sun being covered by the moon. It's just an absolutely glorious sight.
I was supposed to go to the one, was it 2017, was it? In America,
the United States.
And then it coincided with the launch, the very day, the launch of Great Barrier Island's Dark Sky Sanctuary. And so, because we've been so heavily involved, we had to cancel our trip.
Yeah.
And we were going to Idaho, and it had a perfect view, apparently. So we never got to see it, which is very sad. But there you go. Everybody should see one, they say.
Yeah, there'll be one in Dunedin and oh gee, you've got me. I think it's about 2028 or thereabouts.
Oh, not so long then.
Yeah,
We'll still be in lockdown. So
yeah.
maybe we probably won't be able to go, but never mind.
Yeah.
So John, tell us about how the moon actually came about.
Yeah, it's interesting. There have been a number of theories over the years. In fact, it was Charles Darwin's son, George Darwin, who came up with the idea that the moon was actually basically slowing down in its orbit and consequently moving further away from the Earth. And he came up with a theory that when the Earth was spinning faster, a hunk of the Earth, basically from the Pacific Ocean area, flew out from the Earth to form the moon. We now know that hypothesis is wrong, but that was quite an interesting one. There's been a few other ones too, where the moon and the Earth actually formed together in the early formation of the solar system 4.6 billion years ago. Another theory is that the moon was just captured, and that proves problematic in that the moon would have to be traveling at precisely the right speed and into the right area realm of the Earth's gravity to actually be captured. The latest theory since the Apollo missions to the moon between 1969 and 1972, when the Apollo astronauts returned 382 kilograms of rock, plus the Russians actually also scooped up some and sent some, not with manned probes, but with robotic probes. With scientists looking at the moon rocks and so on, they figured that they're very similar to the Earth in some ways, and based on that similarity, in 1975, the idea was put forward that the moon was formed when a planet the size of Mars, which is they've called Theia, Theia. Theia came in, did a glancing blow on the Earth, and mixed up Earth material when Earth was very young and molten, and the material from Theia, which formed a ring around the Earth, and then over the years, that coalesced into the moon.
Where did Theia go?
Well, it became the moon as well as a material on Earth. So some of Theia probably went into the Earth, and some of it became the moon. Plus, some of the material from Earth became the moon.
I
so
heard
that's
that
why our rocks are fairly similar.
I heard there was a Trojan moon. There was another moon as well, and then that just basically coalesced with the moon.
Okay.
That's what I heard, but maybe there are lots of stories about the moon.
Yeah.
Yeah.
No, it's quite interesting just how the Apollo program certainly did open up our understanding of the moon and made us rethink how it possibly formed. Just how the rocks are so similar to the Earth in many ways. So some of the rocks are not quite similar. There's not quite as much iron in the surface rocks of the moon as there is iron on Earth, which makes astronomers think that in the early formation of the Earth, there's a thing called planetary differentiation. And the heavy things like iron and so on sink into the center of the Earth where the main gravity is, whereas the lighter silicate rocks and so on sit on the surface of the Earth. With the moon, there's not as much iron in the rocks on the moon, and that led astronomers to believe that by the time we had that glancing impact with Theia, a lot of the rock iron in the early Earth had sunk to the center to form the inner core and outer core, and so there's less iron on the surface, and then there was the collision with Theia, and so that doesn't seem to be as much iron,
And what's the main? Is there a certain kind of rock there? They drill down with some probes to find out. Did I hear it was granite or something like that?
The three main types of rocks in the return samples were basaltic rocks, which are the dark lava type rocks. All the rocks are basically igneous, which means fire, I believe, in Greek, and that was formed. Sorry, Gareth. 7:50 p.m. Okay, sorry about that.
That's all right.
Okay, so we'll start again, So yeah, it's most of the rocks that the Apollo astronauts returned were, all of them were igneous rocks, which basically comes from the Greek word for fire, and they were volcanic type rocks. And the rocks we found they returned were basaltic rocks, which are dark rocks that they found on the Mare. When you look at the moon, when the listener looks at the moon, you'll see that there's dark areas on the moon, and they're called Mare, and they look like seas. The early astronomers thought they were seas, just like New Zealand. The world has seas and oceans. They thought there was water on the moon, big pools of water, Mare.
Right.
And then there's other areas too, which are the whiter areas, and those are the highlands. And the 6 Apollo missions to the moon returned the rock samples and found that the ones found in the darker areas, the basalt, the Mare, are the basaltic rocks, the dark sort of volcanic rocks. And then around the highlands, you've got the anorthosites, and then there's also breccias, which look kind of like concrete, which are were formed basically from meteorites hit and so on, smashing into the moon and morphing some of the igneous rock.
Of course, if you're observing the moon, it's always great to see it in the crescent, because you can see all of the craters with a shadow falling across them. But once it gets to the full moon, that's not quite so impressive, through a telescope anyway.
Yeah, that's right, Gareth. When you see the moon as a crescent moon or a first quarter moon, the sun is hitting side onto it, and so sometimes you see, it's really neat, you see mountain peaks casting a big long cone like shadow out to the side, and you see the rim of the crater, but the black shadow is still inside the crater. So there's a lot of contrast there. So the best time to actually look at the moon is when it's a crescent moon or first quarter. When people ask me for Gisborne Astro Tours, when's the best time to come and look at the moon, look at the stars, I say, well, probably when the moon is about 4 days to 7 days old. It's not so bright that it's blocking out the stars, but there's enough moon there to actually get amazing sights. It always amazes me that the two things that make people go wow when they look through a telescope are, number one, the moon, and then number two is Saturn.
Yeah. But from the Earth, through a telescope, let's say through the strongest, best telescopes that we have, are you able to see any of the remnants of the American space missions?
No, they're just too small. So with the space probes they put in orbit around the moon since then, yes, certainly they can, with their high resolution cameras, photograph the prints, the tracks of the tracks of the rovers that they had. The last 3 Apollo missions had rovers,
right?
And so yes, they can see the various landing sites and so on. But no, with the largest telescopes, no, not really.
It's interesting, because I was watching a program on the James Webb Space Telescope the other day, and they said that the James Webb Space Telescope is so sensitive to heat, to infrared heat, right? That if the James Webb Telescope was on the moon and it was pointed at your house and you put a bedside light on, the James Webb Space Telescope would be able to pick up that heat signature.
Wow. And that's in the infrared heat.
Yeah.
So
that's, it says it's gives us a lot of hope. That's one of the topics we really must discuss next time, maybe, or the time after, is the James Webb Space Telescope and space telescope, the Hubble as well, because those stories are just truly fascinating, and we're such beneficiaries of the images that Hubble is sending back, and hopefully, James Webb, wow, what's that's going to do for us. But still, carrying on with the moon. So Trojan moon, I always found that an amazing idea, that there was this second moon, but maybe that was just hearsay. One of the things that's always fascinated me, though, is that the moon is actually moving away from us every year, and that in fact, when the moon first formed, it was actually very close to us, and over the billions of years, it's got to what's 384,000 kilometers away. Yeah.
Yeah. So the average distance to the moon is 384,400 kilometers. It's quite interesting. The moon it's not a circular orbit, it's actually an elliptical orbit, and it ranges in distance from 363,000 to 406,000 kilometers. So there's times when it's closest to the Earth, which is called perigee, geos meaning Earth in Greek, and there's times when it's furthest away from the Earth, called apogee, and that can actually give us supermoons. When the moon is closest to the Earth, It can give us a supermoon, and it's about 11% larger than when the moon is furthest away. So the moon does go around the Earth in an elliptical orbit, but interestingly, tis moving away from the Earth at about 3.8 centimeters per year. They think that astronomers believe that when the moon was first formed from the collision with Theia about 4.5 billion years ago, it was a lot closer. It had a lot stronger effect on our tides. The tides were up to about 100 meters high between high tide and low tide. The Earth was rotating faster than it is now, but it was actually, I mentioned him before, Charles Darwin's son, George Darwin, who came up with the idea that the moon was actually moving away from the Earth. And now astronomers use mirrors left on the moon by the Apollo astronauts. They shine lasers at the moon from McDonald Observatory in the United States. Because we know the distance that light travels very accurately, we can very accurately measure or time how long it takes for that laser from McDonald Observatory to hit the moon and then come back. And we can work out the distance to the moon down to the centimeters. Now, over the years, and with observation, we've determined that the moon is moving away from us. And interestingly, as the moon is moving away from us at 3.8 centimeters per year, it's having an effect on the Earth's rotation speed, and the Earth is actually slowing down in its day. And the day on Earth is increasing by I have to read this one, 0.002 seconds per century. So the day is getting longer by 0.002 seconds per century. Might not sound long, but in astronomical terms, it possibly will add up.
Well, I did hear that the moon is very important to us as well, right? It stops us sort of like wobbling too much. Is that right? Something
that's right. We believe that with the steadying effect of the moon around the Earth, it stops wobbles and settles our seasons and so on. So the moon certainly does have a big effect on us. And of course, with tides, the moon at certain times of the day will have an effect on our tides and cause high tides and low tides. It's kind of hard to explain verbally.
You don't say.
Diagram. But if you imagine that the Earth is a circle and the water around the Earth gets squashed into a kind of like how would you explain it? Kind of like an egg shape. And the Earth is actually rotating in that egg shape of water. And imagine New Zealand at some stage is at the egg part where there's not much water there. That's low tide. Then the Earth rotates 6 hours later into that bulgy part of water, and that's high tide. In fact, Neil deGrasse Tyson says that we shouldn't actually say that it's high tide or low tide. We should actually say, or the tide is coming in, we should say that the Earth, or New Zealand, for example, is rotating into the high tide bulge.
Yeah, that's another one of those strange things that everybody says, the moon has an effect on the tide. And I've read lots of things, but I'd have to sit down and study it very closely to feel totally comfortable about how that works. There's something about it that's sort of slightly illogical, as there is with a lot of astronomy stuff, right? Yeah. And if you go into Einstein, of course, then it really sounds like, whoa, this is a bit strange.
That's right. In fact, one interesting thing about the moon is that this seems logical too, is that it's not only the water that actually goes up and down, appears to go up and down from a certain any location on Earth, but the whole landmass around it also goes up and down by 30 centimeters. Yeah. So we have like a full tide of land and a low tide of land as the Earth goes up and down by about a foot.
So the effect when the moon was first up there and it was close, and I don't like to sound like the school swat, but when we did the lunar eclipse in my street, I got a few facts to tell my friends when they were there, so I sounded intelligent. And apparently Just Google, of course, so who knows. But when the moon was first formed, it was only 22,500 kilometers from Earth. 22,500, can you imagine? Wow, it would have been really blasting. It would have been like daylight.
Yes, it would have been. And the tides would have been horrific. And so 22,500 kilometers, the Earth is 12,756 kilometers across.
Right.
So that's roughly 2 Earth diameters.
Wow.
Away. Now the moon has receded to roughly, it's pretty much 30 Earth diameters to the moon. So you see cartoons and books and so on, and it shows the Earth and the moon just sitting a little bit far away from us. In reality, it's 30 Earth diameters to the moon. That's why it took the astronauts 3 days to travel there, to travel at 384,000 kilometers to get there.
And of course, it was the moon that got into Newton's head, right, when he discovered gravity.
Yeah, that's right.
He thought, why doesn't that fly off somewhere?
Yeah.
And of course, this is my elementary understanding, that somehow the moon is actually falling towards the Earth, but because of its sideways velocity, it goes around.
Right? That's right. It's a delicate balance of the Earth's gravity pulling it in towards us, but the force of the speed of the orbit as it's going around trying to fling it away. So it holds it there.
And it was that made him think, well, how is that? And the apple came straight down and the moon went round.
Yeah.
And he used that to deduce that, there must be gravity's affecting both the apple and the moon.
That's right. In fact, we can kind of relate to Newton in that he was in a lockdown when he came up with the idea.
So he was.
Yeah, in the 1660s, the plague was going through Europe, and basically they said, "Go home, stay home for a year." So he went and stayed.
Vaccination rates were really low, apparently.
Yeah, that's right. Yeah, very low.
And Newton took off. He was like going off to Waiheke Island or Great Barrier Island. He didn't hang around. Whoa, I'm out of here.
Yeah, that's right.
Packed up his mule and he was galloping across the Lincolnshire countryside.
Yes,
house.
He was staying at his mother's house, and that's where the apple tree was. That's where he's sitting. And the theory was, the apple tree fell down and made him think.
Yeah. Well, the apple tree fell down. No, that was the guy with the chainsaw.
Sorry, the apple fell down.
That was the guy with the chainsaw. That's another story.
Yeah, that's right. The apple fell down.
The apple fell down. Yeah. So the moon, it's had lots of effects on us, I suppose.
Yes, it has, and it's. I mean, how many poems and songs have been written around the world about the moon? And then you've got the.
I was playing that on the piano just today for my granddaughter.
Oh yeah. No, it's a very beautiful thing, and you were saying that astronomers don't want it in the sky because it does block out the stars, but I must admit, just sitting there and looking at the moon through a telescope or binoculars and looking at the craters. Some of those craters can be up to several hundred kilometers across. And just thinking about it, think about how on the moon, the sunward side of the moon, it's about 130 degrees Celsius. And conversely, on the other side of the moon, that's facing away from the sun at nighttime, it's minus 180 degrees Celsius. So it goes through huge temperature changes. Wow. And it's very small compared to the Earth. In fact, if you brought the moon down, set it right beside the Earth, it would be the same size as Australia. It's about because it's much smaller than the Earth. The gravity on the moon is a lot less. So about 1/6 the gravity of Earth. So you could jump a lot higher. Imagine holding the Olympic game high jump on the moon.
That's right. Because I read somewhere that when the capsules come to Earth, back to Earth, they use our atmosphere to basically slow them down, right? Whereas on the moon they had to use rockets to slow them down because there was so little atmosphere on the moon. So yeah, that's a little sign. They don't use rockets we use those heat shields. So we don't need
Yeah.
to take rockets. So if you're going just around the Earth, if you're going to the moon, you want to land on the moon, you've got to take some fuel up there to basically fire those rockets.
Yep, that's right. So no atmosphere on the moon, no wind, no rain. So the footprints from Neil Armstrong and the other astronauts will last there for millions of years, unless, of course, a rock, an asteroid or something comes in and hits that particular footprint.
Right.
But yeah, and no tectonic plates on the moon. So no earthquakes as such that we have on Earth, but there are moonquakes. When the Apollo astronauts went to the moon, they left seismographs around the moon, and they were able to work using the seismographs. They found that there's about 3,000 moonquakes per year on the moon, and that's partially caused by the tidal effect, the gravitational pull of the Earth on the moon, also caused by the moon cooling down after it's been heated to 130 degrees Celsius. It'll shrink and cause small moonquakes. And lastly is impacts from meteors and so on. They found that the moon gets hit around about 120 times a year by rocks between roughly 100 grams to up to 1,000 kilograms or a ton across each year, and that can also cause a ringing effect on the moon, moonquakes.
Yeah, I'm fortunate that I have got a pair of very large bino telescope, and I use it primarily for looking at the moon. And the balcony in the front of my house allows me to see the moon come up. And when you look at it close to full moon, I can look at it, so you see it in the daytime almost, and it is quite so beautiful. And I think people forget that you can actually see the moon in the day, and it's a beautiful object to look at. And I'm very fortunate with my binos, because I don't get that glare that you get for anybody who's got a sort of an 8-inch telescope. When the moon is close to full, it's not a great experience looking at the moon, because you need filters, and then the filters cut out a lot of the action there. So I love to look at it in the daytime through these big binos, and it is truly stunning. And then at the end of its cycle, right when it's a gibbous moon, get up in the morning, you can actually see the moon setting in the west, which is a wonderful sight as well. It's not, so what I'm saying is, for observers who are listening to this and watching this, that's truly something to enjoy, is the moon, not at night, but either in the evening or in the morning. It's a wonderful sight to behold.
Yes, it is. That's right. There's something beautiful about a sunny day. You're looking up and you're seeing another world sitting in the sky.
Yeah,
it's really, really neat.
Yeah. It truly is it's a wonder. I was walking in the park about a week ago, so it must have been at gibbous time, I guess. And it was just so, or maybe a few weeks back. It's just so wonderful just to see it up there in the day. But tell us, the 1970s, we all thought, oh yeah, or early 70s, this is going to happen, and we're going to be building bases on Mars, on the moon, and then the Americans, ran out of money, and maybe the Vietnam War was all getting to them. They stopped funding it, and we've never gone back. And there's not a person, when we talk about the moon, to talk about the astronauts, don't say, why did we not go back? But we know why, because it was money. But now Elon Musk and all of those guys, they're all talking about going to Mars. They're basically, this is like, the moon, yeah, it's like a motorway cafe or something. We'll give it we won't go there. Does anybody have any plans to actually for humans to go to the moon?
Yes,
again?
Yes, there is. There's apparently there's an Artemis mission. They plan to put people on the moon. Well, I'm not sure if it's going to happen now these days with all the COVID happenings, but they plan to put people back on the moon, men and women, on the moon by 2024.
Who's
3 years from
Artemis?
now.
Who's Art? I mean, that's the
Now,
goddess.
Artemis,
The goddess Diana, if I remember correctly. But I'm
yeah,
sure about her.
so Artemis was a Greek goddess of the moon, the mythological Greek goddess of the moon, and she's the twin sister of Apollo, and of course the Apollo missions going to the moon. So to actually call it Artemis has a strong link to the Apollo missions. They hope to send people to the South Pole of the moon, the lunar South Pole, because they think that down at the pole.
Who's this? Who's this? They?
Oh, this is NASA. It's an American-led team,
NASA.
but it'll be an international. And well, I'm not quite sure if it is NASA. I guess it is, but it's an American-led team, possibly with an international team of astronauts who will go there, land at the South Pole, and they want to go to the South Pole because that's where water probably is. They've discovered water there.
They probably find that Raoul Amundsen has been there.
Who?
Bummer. Oh, yeah. Sorry. Yes. Okay. Good idea.
Yeah.
Good idea.
So of course, water being 2 atoms of hydrogen, 1 atom of oxygen, you can actually get hydrogen for fuel, oxygen for breathing, and use some of it for drinking, of course. And so I guess the idea behind Artemis is to set up a station on the moon where people can live. They're only 3 days travel between the moon and the Earth if things go wrong, and then learn how to live in that base. And then once they've done that, then they can set up a colony on Mars once we sort it out. I mean,
that's faster than sailing to Australia.
Yeah, that's right. Yeah.
If things go wrong.
Yeah, so that'll be exciting. And of course, it'll be very exciting because it will be the first woman on the moon. Because all the 6 astronauts so far on the moon have been men. And so this will be the first lady on the moon. 12
men walked on the moon.
That's right.
And 18 or 24 men visited.
Yeah. No, 18 visited.
No, 24.
Okay.
Because so Apollo 8 went round it. There was 3 on that. And Apollo 13, Apollo 13 didn't land.
Yes, that's right.
Yeah, that was a trick question.
Yes,
that was a trick question.
Yeah.
I've got another little fact which people might like to hear, and that was that only in 1919 did our friendly policeman, the IAU, standardize the name of the moon as the moon.
Yeah, really.
Prior to that, it had lots of names.
Yeah.
Luna and all this kind of stuff.
Yeah.
Italians were making a big bid. No doubt the French had an idea they were going to call it something, La Lune. But no, IAU went with the good old English version, the moon.
Yes, so with the capital M.
With the capital M must have made a big difference. And there were lots of somebody said it came from metri, to measure. Menses, Proto-Indo-European language. I wrote all this out to impress my neighbors.
Oh, good.
I'm sure it did. But as you said, the truth of the matter is, it's all about the moons, right?
Yeah, no, it certainly is an interesting object. And viewers might have looked at the moon, and you'll notice that actually there's always just one side of the moon facing the Earth, which is interesting. It doesn't orbit, so we see the back side of the moon, the far side of the moon. It always keeps the one side of the moon towards us, and it might be because there's slightly more mass off center towards the Earth, and because of that, it's got a synchronous motion, a synchronous orbit where it keeps that one face towards us.
But the other side of it is kind of quite pockmarked, isn't it? It doesn't have the lovely mares.
Yeah, not nearly the amount of mare that the near side has. In 1959, Luna 3, the Russian sent a probe around the back side of the moon, the far side of the moon, and photographed it. Realized, yes, there's a lot less mare, a lot more highlands, and it's got some big impact basins around there, But no, it's the near side that actually has the beautiful seas, or mare. In fact, about 16% of the moon on the side facing, well, actually all over the moon is mare, the darker regions, and about 84% is the whiter parts of the moon.
Well, there you go, John.
Yeah.
Thank you for telling us all these wonderful facts. From my perspective, I would just say to people, start getting out there and looking at it, because it is a truly amazing sight. And for anybody who runs, has a telescope, take it out there and, get the neighbors around to have a look when it's in its early phases, because it's just so wonderful to see those, the shadows creeping across. It's just a fantastic sight. And if
just the craters are just beautiful, and some of them are several hundred kilometers across. In fact, there's about 30,000 craters that are 1 kilometer or more across on the moon.
Oh, well, I had a figure here that there are 3 trillion craters over 1 meter.
Over 1 meter. Wow. Yeah.
Yeah. How about that?
Yeah.
Somebody counted them. It's a lifelong job.
Actually,
lifelong job.
Was
it 2 trillion 990?
Oh damn! I lost
Amazing! Exactly 3 trillion. Who would have thought?
I know. It's quite interesting. Actually, 1 or 2 lunar eclipses ago, I was looking at the moon through my telescope during a lunar eclipse, when you see the Earth shadow moving, well, the moon moving into the Earth shadow. And I got one of the large craters. It was Copernicus or Tycho, one of the two.
Yeah.
And it's kind of hard because the shadow has a slightly fuzzy edge to it. But as the shadow went from one side of the crater to the other, I knew the distance. So say it's 200 kilometers. And then I timed it, and then I could work out how fast the shadow of the moon was going across the moon, which is quite exciting. And in November of next year, next year, 2022, there's going to be another lunar eclipse where the full moon will move into the Earth shadow and have that beautiful red color on it and look like a 3D ball in the sky.
Oh, but I gotta be honest, I was majorly disappointed. I thought it was going, all that talk about blood moon, it looked like a moon that had fallen in some dirt, really, to me. But I did hear that apparently the term blood moon was coined in the time when there was a particular type of pollution in the sky. But since we've cleaned up our act in that regard, and so it no longer looks like a blood moon. Of course, I read it.
Yeah, no, you're right, Gareth. When we look at the moon during lunar eclipses, there's a scale, and I just can't remember the person's name who came up with the scale, some astronomer, and the moon can range from blood red to a darkish color, and that actually indicates how many pollutants, smoke, volcanic eruption, dust, and silicon and so on is in the atmosphere, and will block the amount of light going through, which will impact on how the moon looks. It's really quite interesting.
So it's good news if it doesn't look blood, and it's bad news if it does look blood.
Yeah, that's right. Yeah.
There you go. So when is the next one?
It's in November. I think it might be the 22nd, November 2022.
Oh, okay.
Yeah.
A year's time. Well, the last one was pretty good. I must be honest. And I even had seats out in the garden,
Nice.
so people could look up. But the previous ones had been a disaster with cloudy nights. But this one was really great. And I know that Astrons and Auckland Astronomical Society did a live feed and had an incredible number of hits from overseas.
Yeah.
looking at this live feed of one of the scopes pointing at the moon. So there you go.
That was Andrew Bucknam's backyard, wasn't it?
That's right. Well, you say his backyard, but it's in a rather wonderful spot overlooking the Hauraki Gulf, and it's just sort of like away from a lot of light pollution and the way the moon was coming up.
Yeah.
But I think it would have been him and Steve Dean, I think, somebody. Anyway, it was well attended, shall we say. So it's good. It's good to know there's so many people out there who are, fascinated by it and would look up and take the time. And it was late, it was like 11 o'clock. Although a lot of the people watching were watching from the other side of the earth, so it was the morning.
Yeah, it's quite neat. For the last eclipse, a school came out and stayed the night for Gisborne Astro Tours, and it was cloudy, and the kids were staying the night, and everyone was really looking forward to it. And it was actually Sunrise Christian School, and one of the students prayed that it would clear up, and we would see it, and sure enough, at totality, the cloud cleared, and there we had 20 minutes of beautiful totality, and saw the red moon. And
wow!
And the teacher of that class took a photo through my telescope, and it made the front page of the newspaper the next day. So
wow.
It was really neat to see.
Which paper was that? The Gisborne Times Age.
Gisborne Herald.
The Gisborne Herald.
Yep.
Right. I'll have to check it out on the web. Okay, John. Thank you for that. We've seemed to have been going on for a while, but after all, it's the moon. Who doesn't like talking about the moon? Blue moon. Who doesn't like talking about it? Okay, right. Thank you. I know you've got a lot on at the moment, so I appreciate you taking the time to talk to me about this, and I hope the people listening in have learned something. I certainly have. So we'll come up with something interesting to talk about. Don't forget, I'd love to talk about the space telescopes. I just think they're just so wonderful. So there you go. I'll play us out now with our favorite song.
Okay, thank you, Gareth.
Okay, bye. Take me to Callisto so I can see the stars. I want to view the Milky Way from a terraform base on Mars. From a terraform base on Mars. From a terraform base on Mars.